Hello students, welcome back to my channel. So today we are going to discuss the CBSE board grade 10, the first chapter, real numbers. So this is going to be the part 5 video. I have already explained 4 videos of real numbers earlier. So if you haven't watched yet, so please watch it first, then come to this video. Now let's take a look what we are going to do over here. So here we are going to solve some more problems on the real numbers topic. Okay. So if the first question is, if A and B are two odd positive integers such that A greater than B, then prove that one of the two numbers A plus B by 2 and A minus B by 2 is odd and the other is even. So here one thing is given, that is A and B are two positive integers. So how do we represent positive integers? First of all, in odd positive integers. So we know that if we multiply any number by 2, then the number will always be the even. So now if we add 1 to it, then the number will always be a odd number. So since here is another clue given that A greater than B, so that means B will be the smallest one. So let us consider B over here, 2m plus 1. Okay. Then where we have considered that m is an integer, positive integers. Now what will be the A? A will be the next, if we consider the next odd positive integer, then that will be 2m plus 3, right? So here we have considered A equal to 2m plus 3 and B equal to 2m plus 1. Now what will be the value of A plus B by 2? So let's put the value over here, 2m plus 3 plus 2m plus 1 by 2. Now 2m, if we just group the like terms, so 2m plus 2m and 3 plus 1, 4 by 2. So that means 4m plus 4 by 2. Okay. So if we simplify it, it is coming 2 into 2m plus 2 by 2. So that means 2m plus 2. Right. So 2m plus 2, since 2m is even, and we know that if we add a even number to it, then the number will always be even. So 2m plus 2 will be also even. So A plus B by 2, we got even number. Now let us take the another one, that is A minus B by 2. Since we got A plus B by 2 as even, then we need to prove that the other A minus B by 2 is odd. Okay. So A minus B by 2 will be 2m plus 3 minus 2m plus 1 by 2. Now if we remove the bracket, so minus 2m and minus and plus will become minus, right? So minus 1. So now 2m will be cancelled. Now 3 minus 1 by 2, that is 2 by 2, that is equal to 1. Okay. And we know that which is 1 is an odd number. So that's why A plus B by 2 is 2m plus 2, that is even, and A minus B by 2 is equal to 1, which is odd. So what we got, that one of them is odd and another one is even. Now the next question, express the HCF of 468 and 222 as 468x plus 222y, where x and y are integers in two different ways. Okay. So we need to find the HCF of 468 and 222. So let us do the, here we apply the Euclid's division algorithm. So since 222 is smaller, so we will consider 222 as divisor and 468 as dividend. So 222 into 2 is 444. So now the remainder is 24. So now we know that as per the Euclid's division algorithm, dividend equal to divisor into quotient plus remainder. So that means 468 is equal to 222 into 2 plus 24. Okay. Now this 24 will become the divisor and 222 will become the dividend. Okay. So 24 into 9 is 216. So 6 will be the remainder. So now 222 will be the dividend. Divisor is 24 and quotient is 9 and remainder is 6. Now 6 become the divisor and 24 will become the dividend. So 6 4s are 24 and there will be no remainder. So now 24 is equal to 6 into 4 plus 0. Since we got the remainder as 0, so at this step we will stop, and whatever be the divisor value, that is going to be the HCF. That we already know. So HCF is equal to 6 over here. Okay, now what we need to prove, what we need to show that this 6 is equal to 468x plus 222y. That we need to express. Okay. So now if we take a look, 222 we are representing as 24 into 9 plus 6, right? So now 222, if we just in the equal sign, if we put it in the other side, then 222 minus 24 into 9, that is equal to 6. So what we got, 6 equal to 222 minus 24 into 9. So that is 6 equal to 222 minus 9 into, we can alternately write it 9 into 24. So 6 equal to 222 minus, now 24 we can write it as, if you take from the equation 1, so 24 can be represented as 468 minus 222 into 2. If we just check the equation 1, from there we can represent it as 468 minus 222 into 2, right? So now put that is 6 equal to 222 minus 9 into 468. Now basically we are doing the distributed law over here, we are applying. So minus it will become plus 9 into 2 into 222. So 6 equal to 222 minus 9 into 468 plus 18 into 222. So that is 6 equal to 222. Now just rearrange it. 222 plus 18 into 222, we'll just trying to rearrange. Okay. Then minus 9 into 468. Then here if we take a look, that 222 we can represent at 222 into 1, right? So we can take common as 222, then 1 plus 18 minus 9 into 468. Because our main target is to make sure that 6 can be represented as 468x plus 222y. So we have to make this form. So 6 equal to what we got, 222 into 19 plus minus 9 into 468. Okay, or 468 into minus 9. Now if we rearrange it, then 468 minus 9 plus 222 into 19. Now we can clearly see that it is in the form of 468x plus 222y, where x value is 9 minus 9 over here and y value is 19. Okay, so this is the and also x and y are the integers, right? So this is the way we have to prove it. So basically whatever we have done in the Euclid's division algorithm, the steps, from there we derive this. Okay, so I hope this is clear, because this is a bit tricky problem. So 6 equal to 222 into 19. Now earlier we got what? Let me again go back. Okay, so we got to 222 into 19 plus 468 into minus 9, right? Now we can also represent it as, if we just add a 0 to it, so that means if we add a 0 to it, then 468 into 222, and if we subtract the same thing, then we will always get 0 over here, right? So 222 into 19 plus 468 into minus 9 plus 468 into 22 Now basically we are just removing the third bracket, minus 468 into 222. Now group the 222 one. So 222 into 19 minus 468 into 222, and group the 468 one. So 468 into minus 9 plus 468 into 222. So 222 into, now apply the distributive law, into 19 minus 468 plus 468 into minus 9 plus 222. So 222 into minus 449 plus 468 into 230. So this is the another form of representing the 6. Okay. So here if we compare this with x and y, then x will be 213 and y will be 449. So this is the, since they have asked us to represent in two ways, so this is another way. So earlier one of the first one, and we can also represent this 6 as in this way, where x is equal to 213 and y equal to 449. Okay, I hope this is clear to you. I know this is a bit difficult way to solve. Okay, but I hope I tried to explain in a simplified way. So I hope it is clear to you. If still you have any doubt, then just go back and watch it once again. Then I hope it will be clear. Now coming to the next problem. If D is the HCF of 56 and 72, then find x and y satisfying D equal to 56x plus 72y. Also show that x and y are not unique. Okay. So what we need to find out? First, we need to find out the HCF of 56 and 72. So let's apply the Euclid's division lemma to 56 and 72. So since 56 is smaller, so that will be the divisor and 70 will be the dividend. So now the remainder will be 16. So we can represent 72 equal to 56 into 1 plus 16. So dividend equal to divisor into quotient plus remainder. Now this is equation number 1. Now here remainder is 16. So we consider the divisor now as 56 and remainder so as 16. And now if we apply the division, again apply the division lemma. So now what will happen? 16 will become the divisor and 56 will now become the dividend. Okay. So now 16 3s are 48. 8 will be the remainder. So now if we write it in the Euclid's division lemma form, then 56 equal to 16 into 3 plus 8. This is equation number 2. Now we know that remainder is 8. So now 8 will be the considered as the divisor and 16 will be considered as dividend. So again divide it. So 8 to the 16 and now there will be no remainder. So 16 can be represented as 8 into 2 plus 0. So since we got the remainder as 0, so now whatever be the divisor value, that is going to be the HCF. Right? So here in this case, 8 is the HCF. So here in this question, if you take a look, if D is the HCF, so that means we get D equal to 8 over here, right? If D is the HCF of 56 and 72, find XY satisfying D equal to, okay. Now we need to represent this 8 equal to 56x plus 72y in this form. So same way, whatever we did in the earlier one. So we have to consider 56. If we take a look at the equation number 2, 56 minus 16 into 3 is equal to 8. Okay, let us write this first. Okay, so that is equal to 56 minus, now let us write 16 from equation number 1. So 16 can be represented as 72 minus 56 into 1. So let us write this. And 3 will be remaining as it is. Okay. Now 56 minus, now let us do the distributive property, apply the distributive property. So 72 into 3. Now 56 into 1 means 56. So 56 into 3. Now since it is minus 56, so and also the outside the bracket we have negative, so it will be plus 56. So plus 56 into 3. Okay. So now let us group this 56 part. So 56 plus 56 into 3. So since 56 can be represented as 56 into 1, so 1 plus 3, that is equal to 4, minus 72 into 3. Now here we can clearly see that 56 we can represent it as in the form of 56x plus 72y. So 56 into x means here 4, and 7 in the form they are asking plus 72, so 72 into minus 3 we can write. So here if we compare this with the 56x plus 72y, so x will become 4 now and y will be minus 3. Okay, so x is 4 and y is minus 3. So what we can see that x and y are not unique, means they are not same. Okay, now we got one value of x and y. Now we have to check that there can be other values also. So now let us represent 8 in another way. That is 8 we got 56 into 4 plus 72 into minus 3. Now what we can do, we can represent this if we just add a 0 to it. So 0 can be represented as 56 into 72 minus 56 into 72, because that will give you the 0. So just add a 0 to it. Now group the 56 together. So 56 into 4 and 56 into 72. Okay. Now group the 72 together. So 72 into minus 3 and minus 56 into 72. So now if we take 56 common from there, so 4 plus 72, and in this case if we take 72 common, then minus 3 minus 56. So 56 into 76 plus 72 into minus 59. Now if we compare this with 56x plus 72y, so what we got, that x equal to 76 and y equal to minus 59. So they asked us to prove that okay, x and y will be always different. Whatever x and y value we will get, that will be different. So you can see that we can represent x and y in different ways. So they are not unique. Okay. Unique means there should be, whatever you are applying, you will get only one value. But in this case, you can get multiple values. So that is why it is not unique. Okay, that's all for today. Okay, I hope you have understood this. I know these problems are a bit tricky. So if you haven't still understand it, so please rewatch it once again. I hope that will be clear to you. Okay. So if you like my video, please hit the like button. And if you have any comments, you can always put that in the comment section. Please share this video with your friends and don't forget to subscribe. Otherwise, you will not get notification for the upcoming videos. Thank you. Bye bye.